Welcome back, ladies and gentlemen. The goal of this video is to define the triangle angle bisector theorem and utilize it in some mathematical application in order to solve for a missing segment length. So what does the triangle angle bisector theorem tell us? Well, let's break down the angle bisector part. Remember, angle bisector means to split an angle in half. So in order to do this, we are going to split one of the angles of a triangle. And when we split one of the angles of a triangle in half, it does it in such a way that it divides our opposite side proportionally to one another. What does that mean? Well, it means specifically that it does it in a way where AD is relational to DB just as the other side length CA is to CB. And in class and maybe in a future video, we'll look at the actual proof behind this, because it's actually kind of interesting proof that we have. But that's what we need to know for now. Let me color code these a little bit as well. What do we see? We see that AD is to DB and different color change, just as AC is to CB. We're matching up blue to blue, purple to purple there. So how does this work in application? Well, the triangle angle bisector theorem works in application in something similar to this. We first realize that QPR is congruent to RPS. That is key because it identifies that it's an angle bisector. Now that we know it's an angle bisector, it wants to know what the length of RS is. Okay, it wants to know what the length of RS is. So what do I see? Because an angle bisector, QR is to RS, just as, change colors, just as PQ is to PS. So I know that QR is to RS, just as PQ is to PS. Well, let's just substitute some stuff that we know on in. All right, QR. Well, what about QR? What is QR? I don't see anything there for QR, but what do we know about QS? The whole value of QS, is 15, and RS is X. So if the whole thing is 15, RS is X, what is QR? Well, it's 15 minus whatever the X is. So QR has a value of 15 minus X. RS, we said, was X. PQ is 7, and PS is 13. So now we just put ourselves into a situation where, yes, we have two variables, but it's not going to be an issue for us. Let's see why. Let's cross multiply. We get 7x equals 13 times 15 minus x. We have a distributive property that we're going to put on into play. So 15 times 15 is 195. So I'm just move this up here. We get 7x equals 195 minus 13x. And now we're just combining some like terms. So now we end up saying that when we add 13x over, we get 20x and 195. And 195 divided by 20, x came on out to be 9.75. And let's just make sure if we wanted to find, it wanted RS, x is RS, so yes, RS equals 9.75 in this case.